Hello, today I would like to introduce Java Reflection. For that, I've created two classes. One, it's called user, and the other, users service. With these classes, we will explore a little bit how to inspect a class, methods, fields, and constructors. Okay, so the user, it's a common user class that can be represented in a table in a database, like username and password and email. I added this email as public, but it's not a good practice, but it's just for educational purpose. For sure, in production, this field should be like the others private, and then we can create a get or set or both, depending on the requirements. Okay, then the user service, it's a class, a business class, with common operations like get all users, get user by username, generate password, which is private. The main idea of this class, it's not that we want to execute this code. This is just a fake class or a mocked class with a user that I create inside the method. I don't go to a database or collect these users for any other external place. Okay, but the idea is just to explore a common bin in Java where the properties are the most important, uh, let's say, components, and another class where the methods are the most important operations or components of the class, and that's what distinguishes, let's say, a bin from a business class. Okay, let's go to the main. I already created the code, so you don't have to wait for me to write it. So I created four methods, one that show class, the internals of a class, the other one for fields, the other one for methods, and the other one for constructors. There are other objects that we can inspect using reflection, like annotations, parameters, and so on, but that will be the subject for future videos. Okay, let's start with showing the details of a class. So the first thing that we should do is to get the class from an object, or you can go directly to a class. So if we have an object like user, we can get the class using this method get class, and it returns, um, let's say, an object with the class data type. In reflection, the type that represents a class, it's called class, with, of course, with the C capitalized. Okay, and this we can check internally user class, and you can see that you have a lot of methods that you can collect from a class. Declared constructor, names, methods, um, annotations. If we can test if it's primitive, or if it's assignable from. It's very good to understand if the class can be, when you have polymorphic constructions, it's very useful to have this is assignable from. Get method, array type. There are a lot of things to explore here. In our case, we just explore the simple things because this is an introductory video, and but it will be very useful to understand the reflection. Okay, the first thing that I want to highlight is these three calls that I'm doing here. One is the get name. I'm going to the user class. This gets the name of the class. This get simple name gets also the name of the class, and the get canonical name gets to the name of the class. What are the difference between them? Okay, let's just play. I will just then comment this line. Okay, and do play. Okay, just a few seconds. Yeah, okay. This is the three first lines like this. The name, it's the binary name. The binary name represents internally the name of the class, and usually it is composed by the canonical name, which is this one. You can see here, and the canonical name, it's the one that we use in the import. Okay, the simple name, it's just the name of the class, like when we are declaring a variable, and the binary name seems equal to the canonical name. This is the get name, but it's not. Imagine it's how internally Java sees the class. What is the difference in practical terms? If you have an inner class inside our user, then you will see a dollar and then the name of the class after it. It can be bigger if you have inner class inside. There are this kind of small difference. It should be completely unique when it's running, when the class is running. This is how the Java internally, when it's executing your code, sees the class. That's why you have three different ways to extract the name of the class with, of course, different purpose. Then from the class you can get the package too, and you can see here the package where this class belongs. And if you want to check the superclasses, you can always use the get superclass, get name, and of course this returns an object with other methods that you can collect that we should see in future videos. Okay, this is the first approach, and it seems a very simple approach, but if you think for a while with this information where you can get superclass, for instance, and the names, you can, for instance, use uh, a diagram tool or develop your own diagram tool. Maybe you can start with text and create a tree. When you have a class and you get a superclass, you can do a loop and try to find the other superclass from this superclass and so on. So you can draw a completely tree, for instance, on the first version as a text. And then later you can get some frameworks that already exist that can help you to generate a diagram. That's one of the great things about reflection, is that simple things can create value, let's say frameworks with value, things that you can explore and use in your applications. Okay, this is about the class. Now I will comment the class and let's see the fields. This one, I will just then comment here and it should be simple to understand. Okay, this is the class and let's now this is about the field. So I'm passing here the class user, and again I'm getting the class, and then we have a method in the class again from the class, let's say in reflection, and do we have a method called get declared fields, but we have another one that I have commented here named get fields. We will see in a moment the difference. Okay, let's just execute, okay, which by the way, the field of course is expected. It's the name of the class that represents a field, and method for method and constructor for constructor. Okay, we'll see in a moment these data types, but for now let's just focus on fields, but just to highlight the fact that in reflection it's very intuitive. If you are trying to find an annotation, for sure you have a class name of annotation. Okay, let's just run it. Okay, and you can see the three fields: username, password, email, and I'm getting the field get name, which is the first one, and then the data type. The data type, of course, it's a class, but it can be a primitive, and there are methods to check if it's primitive or not. But in this case, I just displayed the get data type, which returns a class, and you can get all the information that we saw when we were exploring the methods related with the class. Okay, this is about the fields, and we are using the get declared fields. Get declared fields means that are the fields declared in this specific class. Okay, and it's declared. It's like asking, okay, when the developer created this code, which fields were declared in this specific class? And if you go there, these are the three fields declared in the class, and this is what is displayed. Okay, what about if I comment this line? And now, rather than use get declared fields, I'm using the get fields. Get fields, it's all the fields. Okay, but with a tricky thing. It's all the fields from the point of view of Java when it's running your code, or with like as if you were the developer, meaning that you will not see the private fields. You only see the public ones. Because when you are executing code, or when you are developing code and compiling the code, only the publics are protected, depending on, of course, how we are designing our application, will be visible. The private ones will never be visible. And if they are not visible, the get fields, that's why there is a distinction between declared and not declared here. Okay, the private ones will not appear. Let's see. Okay, so we can only see the email because email, it's public. So it's something that we should know. This is important because maybe you want to use a reflection, but using the, let's say, the normal rules of the object-oriented, because you are using reflection for a business use case. But if you are using, for instance, the reflection to develop the framework, now for that, it's important for you to access usually things that are not accessible in a normal code, and that's why the reflection provides you methods called get declared something, and this declared get declared exists for fields, methods, constructors, and so on. Okay. Now let's see for methods. It's the same thing as you expect. This is quite simple. Okay, let's expand for methods. And now I'm using not user, but user service because we are targeting methods. So it makes more sense to use a business class. Okay, so for methods, it's the same thing. You have the methods and you have declared methods. I'll just execute this one, declared methods first, and then we'll check the others. And again, you get declared methods, which returns an array of methods, and then you can loop and get method name, and you can ask for the return type, not the data type. Of course, the method doesn't have a data type. It has a return type and the parameters, and get simple name. There are a lot of things related with method that I'm not putting here. This is just an introduction. But for instance, you can invoke a method. You can really invoke a method. You can search for a method using reflection and execute the method. Get the number of parameters. Get annotations around the method, that exception type, generic set, a lot of things, the modifiers, if it's public, private, and so on. But that for future videos, as I said before. I know I'm repeating a little bit myself, but just to make sure that the scope of what we are now saying, it's just introductory material. Okay, so methods, get name and return type, get simple name. Let's just execute so you can see the output, and it will be not debug, but it's the same. Okay, so we can see here. Okay, this is probably because the constructor. You see that I'm just printing an object, which is the object that was created, just an object, because we have this private constructor. Okay, but the methods here, which is the result of the execution of this method. Okay, so we have generate password, which is private, but we are asking about declared methods. As said before, it displays all the methods declared in the class user service. So we have generate password, get all users, and get user by username, which are the three methods here. Okay, the constructors are not considered methods; they are special methods and they have a special data type called constructor that can be used to collect them. Okay, and again, it's just a method. You get the name, get return type, get parameters. We have a lot of things that we can get, but this simple code can display all the methods, and if you want, you can just invoke a method if you want. Okay, now let's just uncomment this line. Now let's get the methods. Okay, and we have a private one and two publics. Okay, let's play and see what happens. And we can see that a lot more methods on the output. So we have these two methods, not the private one, because when we are not using declared, it behaves like if we were, let's say, in a context of normal circumstances about object-oriented, which means that private things are not accessible from outside. Not even reflection tries to get them unless we use the declared, which is not the case. So we get the two methods that are public, but not, which is this one, but not this one, okay, which is private. And we get other methods. And if you check the name of these methods belong to the object, because any class extends from the object, and these methods are public in the object. So it will be displayed also. That's one of the big difference between these prefixed methods called the get declared something and without the declared. The declared, it's only specifically for the class user service. The methods returns all the methods that are visible. If you have an hierarchy, imagine that user service inherits from another class, which by the way has 10 methods, which by the way extends from object. So we will see all these methods from object, we will see the methods from user service, and all the methods belonging to the class that could be in the middle between the object and user service. That's one of the things that we should be aware. That's one of the big difference between using the declared and not using the declared. Okay, and now the constructors, which are important components in reflection. And it's the same concept. You have declared constructors and constructors again. but the constructors are not considered methods. They are special methods in a way that return an instance of its own class. Okay, so we have the get declared constructors, which returns an array of constructors, and then we can get the name and parameters like any other method. One of the great things is if we need like this. Okay, I don't want to get accessible. Oops, constructor. We can create a class like this, new instance, and even when we have parameters here, if it supports overloading, which means that if we have multiple constructors and we create an instance, it will check how many parameters are we adding on the new instance, and it will try to find automatically the correct constructor. You can see this as a kind of I'm pushing too far, but it's a first step for frameworks like dependency injection and things like that. When you need to create a class, but it depends on another one, and you want to create the other one. So when we are creating a new instance, okay, you will try to find the correct constructor, okay? But it's something that I will show you in future videos. I already developed myself a small dependency injection framework, and I will show you in the future how you can develop it also. So one of the advantages of this kind of approach when we are learning this or when we are trying to develop these frameworks is that we understand deeply how they work. So when we are using them in other frameworks, we understand when there's something wrong happens and we don't understand quite well the error. If we in the past we developed something similar, maybe it will help us to understand better these new frameworks. One of them very popular is, for instance, Spring Boot. Okay, so this is the constructor. Let's execute. And again, I'm displaying there are two constructors. One is private and the other one is public. Okay, this one and this one. This one has one parameter, and it's what I'm displaying here: constructor get parameter count. And of course, it's just one. But if you want, you can display, for instance, the data types of the parameters. By the way, um, Java does something called type erasure, and which means that if you have generics, for instance, the virtual machine usually don't keep the data type of the generic instruction. And for instance, even for parameters, internally the parameters are called arg0, arg1, arg2, arg2, and so on. The names that we use in when you are developing, they are for you, not for Java. Java internally use its own name. So if you are doing reflection and you are trying to find methods with specific parameters by name, it will never work. The only thing that you can do is try to find methods or constructors with specific data types on the on the parameters. That's why you have overloading by data types and not overloading by parameter names. Okay, that's one of the things that you should understand about reflection. Okay, these are the four things that I wanted to show you in this introductory video. In further videos, I will explain more deeply each one of them. I hope that was useful for you, and I hope to see you in my future videos. Thank you.